Hey everyone, and welcome back. Today we're diving into a world that honestly you might not expect. Oil exploration.
Oil exploration.
I know, right? But stick with me, because this isn't about like greasy rigs or anything. This deep dive is about how data can uncover hidden treasure. We're talking cutting-edge science and seriously clever data work.
Sounds more like Indiana Jones than an oil rig. I like it.
Exactly. It's all about finding those valuable oil deposits, but in some of the trickiest places on Earth.
Okay, I'm intrigued. So, where are we exploring today? What makes these oil deposits so hard to find?
Well, we're diving into something called Vuggy Carbonate Reservoirs.
The carbonate reservoirs.
Yeah, specifically, we'll be looking at aption carbonates. They're rock formations that are often found in places like Egypt and are super important for oil production.
So are they like those massive oil fields you hear about in the Middle East? Just like a giant pool of oil underground?
Not exactly. See, the Vuggy part means the rock is full of holes and gaps.
Kind of like a sponge.
Yeah, exactly. And some of those holes are filled with oil, but some are filled with water.
So it's not a uniform layer of oil just waiting to be tapped. That's where the challenge comes in, huh?
You got it. Telling those apart just by looking is basically impossible.
So how do oil companies typically find oil in these reservoirs?
Well, traditionally, they use a combo of rock physics analysis and, well, logs.
Well, logs, right. Like
Yeah.
measurements they take when drilling.
Exactly. But these methods often depend on really specialized tools and data.
And I'm guessing that gets expensive.
You know it. And sometimes those tools can miss some pretty important things, like, is that pocket of fluid oil or water?
Yeah, that's a pretty crucial detail to miss if you're drilling an oil well.
Right. There's so much money on the line, and they could end up drilling in the wrong spot.
Makes sense. So is that where this new research comes in? Finding a better way to locate the oil-rich zones?
You got it. That's exactly what we're going to explore in this deep dive.
All right, tell me more.
Yeah.
What's like the main idea behind this new approach?
Well, researchers have found a way to use data that's already available, the kind of measurements taken in almost every single oil well.
So they're starting with basic data.
Yeah. But then they apply some pretty clever data tricks. It's like a detective, using simple clues to solve a really complex case.
Okay, so using existing data is a huge cost saver. But what kind of data tricks are we talking about?
Well, it's actually a whole bunch of different techniques. First, they got to transform the basic well log data.
Transform it how?
Well, they turn it into a much richer set of information, almost like giving that rock formation its own fingerprint.
Okay, so they're pulling out more meaning from like the same basic measurements.
Precisely. Then they use a technique called principal component analysis.
Principal component analysis.
Yeah, it's also known as PCA. It's a way to simplify the data without losing the really important info. Kind of like squeezing all the juice out of a mountain of oranges.
So they get this concentrated dose of the most useful data.
Exactly. But here's the coolest part. They use data visualization to find hidden patterns and relationships.
Data visualization, like graphs and charts.
Exactly. It's like connecting the dots in a giant puzzle.
Wow, so they're making the data tell a story.
Exactly. They're revealing those patterns, and those patterns tell us where to find the oil. They even take it a step further and train a machine learning model.
A machine learning model? What for?
To predict the likelihood of finding oil, water, or a mixture of both in different zones of that reservoir.
So they're like teaching a computer to pinpoint the good stuff.
Exactly. And the results are really, really impressive. The model got over 85% accuracy just by using the basic, log measurements.
Maybe 5%. That's really good.
Right.
Especially with just basic data.
Right. It's a game changer for the industry. But it's not just about oil companies, It also matters for us.
Okay, how so? I'm all ears.
Well, think about it. More efficient oil exploration means lower costs for those companies.
And that could trickle down to like lower gas prices for everyone.
Now you're talking my language. But seriously, this research has implications beyond just oil.
You mean like other industries?
Absolutely. It's a great example of how data science can revolutionize traditional industries, from finance to healthcare.
So we're talking about new solutions for all kinds of complex problems.
Exactly. And this research just shows that sometimes those answers are right in front of us, hidden within the data we already have.
It's just a matter of asking the right questions.
And applying those clever data tricks. Now, I want to hear more about how these researchers actually did it. What were the key steps to unlocking those hidden insights?
Okay, let's get into the nitty-gritty.
It's like following a recipe, but for data. They had to get all their data ducks in a row
Get
first.
their data ducks in a row.
Yeah, get it all clean and consistent before doing any serious analysis, like prepping ingredients for a really complex dish.
Makes sense. So what comes after the data prep?
Well, that's when they start applying those data tricks we talked about, like feature engineering.
Feature engineering. Remind me what that is again.
It's basically transforming the raw data into something more meaningful. Like, think of it like taking basic cookie dough and adding all kinds of flavors and textures. Chocolate chips, nuts, sprinkles.
Ah, so you're not just looking at plain dough anymore. You're adding complexity and making it more interesting.
Yeah. They did that by creating over 200 different metrics.
200. That's a lot of metrics.
I know, right? For example, instead of looking at just the average value of something called deep resistivity,
Deep resistivity.
yeah, it's a measure of how well the rock resists electricity. They also looked at how much those individual measurements fluctuated.
So they were looking at the variations within the data itself. What's the point of that?
Well, it tells you something about the heterogeneity of the rock formation.
Heterogeneity, you mean like how much variation there is in the rock?
That's it. Some parts might be more porous, some might have higher resistivity, which, makes finding that oil even trickier.
So by looking at those fluctuations, they're getting a more detailed picture of the reservoir structure.
Exactly. And with more metrics, they can give their machine learning model a much richer picture to work with.
Makes sense. But with 200 metrics, that's a lot of information to process. Did they have a way to manage all that?
They did. That's where principal component analysis comes in, or PCA, remember?
Right, the orange juice squeezer.
Yep. PCA helped them reduce those 200 variables down to just 24.
Wow, so they decluttered their data without losing the good stuff. But how does it know which variables to keep?
Well, PCA is a bit technical, but essentially it looks for variables that explain the most variation in the data, like finding the key ingredients that give a dish its unique flavor.
So it's pinpointing the data points that really matter.
Exactly. And by reducing the number of variables, their analysis became much more manageable.
Okay, so they've got this concentrated data all prepped and ready to go. What's next?
Well, remember those hidden patterns we were talking about? That's where data visualization comes in.
Right, turning data into pictures. That must have been helpful.
It was. Data visualization is kind of like having X-ray glasses that reveal the hidden structures of the data.
So instead of just staring at spreadsheets, they created visuals to see the bigger picture.
Precisely. And they created a bunch of different visualizations, but one of the most insightful was a simple scatter plot.
A scatter plot. What did that show?
It showed the relationship between average deep resistivity, which we talked about before, and something called average effective porosity.
Effective porosity. Remind me what that is again.
It basically refers to how much space there is within the rock for fluids to flow through.
Got it. So they plotted these two variables, and what happened?
Well, they had their aha moment. They discovered something really interesting. Zones with an average deep resistivity of less than about 55 ohms were usually just water or mist flow.
Less than 55 ohms, mostly water.
But zones with higher resistivity, those were much more likely to have oil.
So they found this, like, magic threshold in the data, a dividing line between the good stuff and the not-so-good stuff.
And all thanks to data visualization. It's like drawing a line in the sand, separating the treasure from the, everything else.
That's incredible. So now they can use this simple measurement to target their drilling efforts.
They can. It's like having a treasure map, guiding them to the most promising locations. But they didn't stop there. They took this data-driven insight and went even further with machine learning.
Machine learning.
They wanted to create a model that could predict the contents of each zone, whether it was oil, water, or that mist flow.
So instead of relying on just that single resistivity measurement, they wanted something more sophisticated.
Exactly. A tool that could account for all the different nuances in the data.
That makes sense. So what kind of machine learning magic did they use?
Well, they used something called quadratic discriminant analysis, or QDA for short.
QDA. I'm guessing that's not as simple as it sounds.
Not exactly. But think of it like this. Imagine a detective analyzing clues to solve a case. QDA is like that. It looks at all the data and makes a prediction.
So it considers all the evidence to determine the most likely outcome.
Exactly. Like a super smart detective with a data-driven magnifying glass.
I like it. So they trained this QDA model.
Yeah.
How did it perform? Did it live up to the hype? It's pretty amazing how this research team used a model that's been around for ages and managed to make a huge discovery.
Yeah, like they dusted off this old, reliable tool and figured out a brand new way to use it.
Right. Sometimes the best solutions aren't about inventing something completely new, but about applying existing knowledge in a different way.
Absolutely. So let's dive into this QDA model. You mentioned quadratic discriminant analysis. Can you break it down for us non-statisticians? What's happening under the hood?
Okay, imagine you have a basket of fruit. Apples, oranges, and pears, all mixed up. Each fruit has unique characteristic size, shape, color, and even how it feels.
Okay, I'm picturing it.
The QDA model is like a set of rules that can look at those characteristics, those clues, and figure out the probability that a piece of fruit belongs to each category. Is it an apple, an orange, or a pear?
So like a super smart sorting hat for fruit, but instead of magic, it uses math.
Exactly, a data-driven sorting hat. And in our oil exploration case, the fruits are the different zones in the reservoir.
Okay, and the characteristics are all those metrics they got from the well log data, like resistivity and
You
porosity?
got it. The QDA model takes all that data, crunches the numbers, and tells us how likely each zone is to contain oil, water, or that mist flow.
So like a probability score for each zone?
Yeah, it's like having a meter that tells us where the oil is probably hiding.
Okay, but how do we know if this QDA model actually works? How well did it perform?
Well, they tested it rigorously using something called K-fold cross-validation.
K-fold cross-validation, we've talked about that before, haven't we? Can you give me a quick refresher?
Imagine you're baking cookies, right?
Yeah.
And you want to make sure they all taste good, not just the first one.
Makes sense. You wouldn't want a whole batch of bad cookies.
Right. So with K-fold cross-validation, you divide your data into, let's say, 5 groups.
Okay, 5 groups of data.
You use one group to test the model, like taking a bite of one cookie, and the rest to train the model, like adjusting your oven temperature or baking time based on that first cookie.
Okay, so you keep testing on different groups to make sure the model consistently bakes good cookies, no flukes.
That's a great way to put it. And that's what they did here. They tested the model on 5 different subsets of the data.
And how did those tests turn out?
The model achieved an average accuracy of over 85%.
Wow, 85% across all the tests. That's impressive.
It is. It means we can be confident that it's not just a one-time fluke. It consistently predicts where the oil is.
Okay, so they tested it thoroughly, and it passed with flying colors. But they didn't stop there, did they?
No. They also tested it on a completely separate data set that wasn't used during the training, like giving the model a brand new recipe and see if it can still bake those delicious cookies.
A true test of its abilities. So how'd it do?
It still performed incredibly well, getting about 83% accuracy.
Okay, now I'm seriously impressed. But I'm curious, how exactly did they measure that accuracy?
They used a tool called the confusion matrix.
A confusion matrix. That sounds kind of complicated.
It's not as bad as it sounds. Think of it like a scorecard for the model.
Okay, a scorecard.
It shows us how many times the model correctly predicted oil, how many times it correctly predicted water, and so on. It also shows us where it made mistakes.
Ah, so it's like a report card showing us where the model excelled and where it needs improvement.
Exactly. And in this study, the confusion matrix showed that the model was really good at finding the oil.
So an A-plus student when it came to pinpointing the good stuff.
Exactly. It also showed that the model sometimes got confused between water and mist flow. So maybe a B student in those areas, but still passing.
So the confusion matrix isn't just about evaluating the model, it's about figuring out how to make it better.
Right. It helps us identify the areas where the model needs more training. Kind of like a tutor focusing on a student's weaknesses.
That makes sense. This whole process is like a detective story, gathering clues, analyzing evidence, and trying to solve the mystery of where the oil is hiding.
It is, isn't it? And in this case, the researchers did a phenomenal job. They essentially gave us a treasure map.
A data-driven treasure map.
Yeah.
That's pretty cool.
Mm.
But let's talk bigger picture for a second. What does this research mean for the oil industry and for, the world?
Well, I think one of the biggest takeaways is that data science can make industries like oil and gas more efficient and sustainable.
It's not just about finding more oil, it's about finding it smarter.
Absolutely. By using data to target drilling locations, we can reduce the environmental impact. Plus, it saves companies money.
It's a win-win for the environment and the bottom line.
Exactly. And this research has implications beyond just oil. It applies to any field where resources are limited, and we need to make smart decisions.
So water, minerals, even time. Data can help us manage all kinds of resources more effectively.
Absolutely. Data gives us the power to make better choices, optimize our resources, and minimize our impact on the planet.
That's a powerful thought. But before we get too carried away with the awesomeness of data science, let's talk about some of the challenges.
Okay, good point. It's not all sunshine and rainbows. What kind of challenges are we talking about?
Well, for one, data can be messy. It's not always perfectly organized and ready to
That's
analyze.
true. Real-world data is often full of errors, missing information, inconsistencies. It's like trying to solve a puzzle where half the pieces are missing and some are bent out of shape.
Right. And then there's the challenge of choosing the right tools for the job. There are so many different algorithms. How do you know which one to use?
It's like having a pantry full of spices,
Yeah.
but not knowing which ones to use to make your dish taste good. It takes experience and knowledge to pick the right tools.
And we can't forget about the ethical side of things. Data science is powerful, and we need to make sure it's used responsibly.
Absolutely. Bias, privacy, transparency, these are all crucial issues. Data science can be used for good or for bad. It's up to us to make sure it benefits everyone.
It sounds like data science requires a lot more than just technical skills. You need critical thinking, ethical awareness.
It's a multifaceted field, that's for sure, but it's also incredibly rewarding. If you're passionate about problem solving and want to make a real difference, data science is a path worth considering.
I couldn't agree more. This deep dive has been eye-opening. We've explored the nitty-gritty of oil exploration and the broader implications of data science for the world.
It's been a journey. I hope our listeners are feeling inspired by the power of data to solve complex problems and create a better future.
I'm sure they are. But before we go, I want to touch on one more aspect of this research that's really important. How the researchers made sure their model was reliable and wouldn't mislead us. Remember that separate data set they used to test the model?
Ah, yes, the holdout set. Setting aside data specifically for testing is a vital part of machine learning. It helps to avoid what we call overfitting.
Okay, overfitting. Remind me what that is again?
Imagine you're studying for a test by memorizing the answers to a specific set of practice questions.
Okay, been there, done that. Not always the best strategy.
Right. You might ace that specific test, but if the real test has different questions, you're in trouble. Overfitting is similar. The model gets too focused on the training data and doesn't perform well on new data.
So it's like the model is cramming for the test instead of learning the material.
That's it. But by testing on that separate holdout set, the researchers could be sure the model was actually learning, not just memorizing.
Like giving it a pop quiz to make sure it really understands the concepts.
Exactly. And because the model did well on both the cross-validation and the holdout set, we have good reason to trust its predictions.
So it's a robust and reliable tool. Fantastic. This deep dive has been so insightful. I feel like I've learned a ton about oil exploration and the power of data science.
Me too. It's amazing how something as simple as, well, log data can lead to such groundbreaking discoveries.
It makes you wonder what other hidden gems are waiting to be discovered in the data we collect every day.
That's the beauty of data science. It's a constant journey of exploration, uncovering hidden patterns and connections. And who knows what incredible breakthroughs are just around the corner. It really is amazing, isn't it? How data from, well, logs can lead to these incredible discoveries.
Yeah, it makes you wonder what other secrets are hidden within all the data we collect.
It's like we're explorers mapping out uncharted territory. Data science helps us see patterns that were invisible before.
And those patterns can lead to some pretty big breakthroughs, even in fields like oil exploration that have been around forever.
Absolutely. It's a reminder that innovation doesn't always mean inventing something totally new.
Yeah,
Sometimes it's about using what we already have in a new way.
so true. Now, we've talked a lot about finding oil, but where else could we see this kind of data-driven revolution happening? What other fields could benefit?
Oh, the possibilities are huge. Healthcare is a big one.
Healthcare, yeah. We've got electronic health records, wearables, genetic testing, so much data.
Exactly. Imagine using that data to create personalized treatments, predict disease outbreaks, or even speed up the process of developing new drugs.
It's like having a crystal ball for our health, knowing what's coming and how to prevent it.
That's the idea. And what about finance? We're already using data science to, detect fraud and manage risk.
Right, but what about using it to, create fairer financial systems or give people better access to credit?
Absolutely. We could even use it to predict and maybe even prevent economic crises.
Wow, a financial early warning system. That's pretty powerful stuff.
It is. And don't forget about education. We could personalize learning, identify students who need extra help, even develop better teaching methods.
It's like having a tutor who knows exactly how each student learns best.
Precisely. And these are just a few examples. Honestly, the potential for data science to change the world is limitless.
I'm excited, but also a little overwhelmed by all the possibilities. Data science is clearly more than just a trend.
Oh, for sure. It's a fundamental shift in how we understand and interact with the world. Data is the key to so much.
Well said. It's like we're entering a new era of discovery, and data is our guide. But let's get real for a second. What are some of the challenges data scientists actually face?
Okay, back to reality. Well, like we mentioned earlier, data can be messy.
Yeah, not always perfectly organized in a spreadsheet.
Right, it's often full of errors, inconsistencies, missing values. It's like trying to put together a puzzle with some pieces missing and others bent out of shape.
And there are so many different tools and algorithms. How do you even know which one to use?
It's true. It takes experience to figure out the right approach. It's like a chef knowing which spices to combine to create a delicious dish.
And we can't forget about the ethical side of things. We have to make sure data science is used responsibly.
Absolutely. Bias, privacy, transparency, these are all critical considerations.
Yeah.
Data science is a powerful tool, and we need to ensure it's used for good.
It sounds like being a data scientist requires more than just technical skills. You need to be a creative thinker, understand ethics.
Absolutely. It's challenging, but incredibly rewarding. If you're passionate about problem solving and making a positive impact, it's definitely a field worth exploring.
I couldn't agree more. This deep dive has been an amazing journey. We've learned so much about oil exploration and how data science is changing the world.
It's been a pleasure sharing this journey with you and our listeners. Hopefully, we've sparked some curiosity and inspired some future data scientists out there.
I think we've covered a lot of ground today, but remember, the world of data science is constantly evolving. There's always something new to learn and explore.
That's right. So keep those brains buzzing, everyone.
Until next time, happy exploring.